School of Management Studies IGNOU presents an audiobook on the course MMPC 005 Quantitative Analysis for Managerial Applications for MBA program. Block 4 Forecasting Methods Unit 15 Regression.
After completing this unit, you should be able to understand the role of regression in establishing mathematical relationships between dependent and independent variables from given data, use the least squares criterion to estimate the model parameters, determine the standard errors of estimate of the forecast and estimated parameters, establish confidence intervals for the forecast values and estimates of parameters, and make meaningful forecast from given data by fitting any function linear in unknown parameters. Introduction. In industry and business today, large amounts of data are continuously being generated. This may be data pertaining, for instance, to a company's annual production, annual sales, capacity utilization, turnover profits, manpower levels, absenteeism, or some other variable of direct interest to management. Or there might be technical data regarding a process such as temperature or pressure at certain crucial points, concentration of a certain chemical in the product, or the breaking strength of the sample produced, or one of a large number of quality attributes. The accumulated data may be used to gain information about the system, as for instance, what happens to the output of the plant when temperature is reduced by half, or to visually depict the past pattern of behavior, as often happens in a company's annual meetings where records of company progress are projected or simply used for control purposes to check if the process or system is operating as designed, as for instance in quality control. Our interest in regression is primarily for the first purpose, mainly to extract the main features of the relationships hidden in or implied by the mass of data. The need for statistical analysis. For the system under study, there may be many variables, and it is of interest to examine the effects that some variables exert or appear to exert on others. The exact functional relationship between variables may be too complex, but we may wish to approximate to this functional relationship by some simple mathematical function, such as a straight line or a polynomial which approximates to the true function over certain limited ranges of the variables involved. There could be many variables of interest in the system. In a chemical plant, for instance, the monthly consumption of water or other raw materials, the temperature and pressure maintained in the reacting vessel, the number of operating days per month, the monthly production of the final product, and any byproducts could all be variables of interest. We are, however, interested in some key performance variable, which in our case may be monthly production of final product, and would like to see how this key variable, called the response variable or dependent variable, is affected by the other variables, often called independent variables. By independent variables, we shall usually mean variables that can either be set to a desired value or else take values that can be observed but not controlled. As a result of changes that are deliberately made or simply take place in the independent variables, an effect is transmitted to the response variables. In general, we shall be interested in finding out how changes in the independent variables affect the values of the response variables. Sometimes the distinction between independent and dependent variables is not clear, but a choice may be made depending on convenience or objectives. Broadly speaking, we would have to undergo certain sequence of steps in determining the relationship between variables, assuming we have data points already. Step 1. Identify the independent and response variables. Step 2. Make a guess of the form of the relation, that is linear, quadratic, cyclic, etc. between the dependent and independent variables. This can be facilitated by a graphical plot of the data for two variables on a systematic tabulation for more than two variables, which may suggest some trends or patterns. Step 3. Estimate the parameters of the tentatively entertained model in step 2. For instance, if a straight line was to be fitted, what is the slope and intercept of this line? Step 4. Having obtained the mathematical model, conduct an error analysis to see how good the model fits into the actual data. Step 5. Stop if satisfied with model. Otherwise, repeat steps 2 to 4 for another choice of the model form in step 2. What is regression? Suppose we consider the height and weight of adult males for some given population. If we plot the pair x1, x2 that is equal to height and weight respectively, then such a diagram is conventionally called a scatter diagram. Note that for any given height, there is a range of observed weights and vice versa. This variation will be partially due to measurement errors, but primarily due to variations between individuals. Thus, no unique relationship between actual height and weight can be expected. But we can note that average observed weight for a given observed height increases as height increases. The locus of average observed weight for given observed height as height varies is called the regression curve of weight on height. A pair of random variables such as height, weight follows some sort of bivariate probability distribution. When we are concerned with the dependence of a random variable y on quantity x, which is variable but not a random variable, an equation that relates y to x is usually called a regression equation. Similarly, when more than one independent variable is involved, we may wish to examine the way in which a response y depends on variables x1, x2 till x. We determine a regression equation from data which covers certain areas of the x space as y, which is equal to f into x1, x2 till xk. Linear regression. The simplest and most commonly used relationship between two variables is that of a straight line. Fitting a straight line. Least squares criterion. In fitting a straight line or any other function to a set of data points, we would expect some points to fall above or below the line, resulting in both positive and negative error terms. It is true that we would like the overall error to be as small as possible. The most common criterion in the determination of model parameters is to minimize the sum of squares of errors, or residuals as they are often called. This is known as the least squares criterion and is the one most commonly used in regression analysis. This is, however, not the only criterion available. One may, for instance, minimize the sum of absolute deviations, which is equivalent to minimizing the mean absolute deviation, that is MAD. The least squares criterion, however, has many advantages. They are: number 1, it is simple and intuitively appealing. Number 2, it results in linear equations called normal equations for solution of parameters which are easy to solve. And number 3, it results in estimates of quality of fit and intervals of confidence of predicted values rather easily. How good is the regression? Analysis of variance. ANOVA. Once the regression line is obtained, we would like to find out how good tie fit is. This can be ascertained by the examination of errors. Variety of regression models. The methods of regression analysis have been illustrated in this unit for the case of fitting a straight line to a given set of data points. However, the same principles are applicable to the fitting of a variety of other functions which may be relevant in certain situations. You can refer to your self-learning material for learning about different situations. Seasonal model. The monthly sales for items like woolens or desert coolers is expected to be seasonal, and a sinusoidal model would be appropriate for such a case. Seasonal models with trend. When in addition to a cyclic component, a growth or decline over time of the demand is expected, a cyclic trend model of different kinds may be more suitable. Multiplicative models. Often by a simple transformation, a non-linear model may be handled by the methods of linear regression. Linear and non-linear regression. We have understood that many non-linear models can be transformed to linear models by simple transformations. It is to be noted that we are referring to linearity in the unknown parameters, so that any model which can be expressed as equation is called linear. For such a model, the parameters can be obtained by the method of least squares as the solution to a set of linear equations known as the normal equations. Non-linear models which can be transformed to yield linear models are called intrinsically linear. Some models are intrinsically non-linear. Some kind of interactive methods have to be employed for estimating the parameters of a non-linear system. Now let's summarize the unit. In this unit, fundamentals of linear regression have been highlighted. Broadly speaking, the fitting of any chosen mathematical function to a given data is termed as regression analysis. The estimation of the parameters of this model is accomplished by the least squares criterion, which tries to minimize the sum of squares of the errors for all the data points. How the parameters of a fitted straight line model are estimated has been illustrated through an example in your self-learning material. After the model is fitted to data, the next logical question is to find out how good the quality of fit is. This question can be best answered by conducting statistical tests and determining the standard errors of estimate. This information permits us to make quantitative statements regarding confidence limits for estimates of the parameters as well as the forecast values. An overall percentage variation can also be computed, and it serves to give a score to the regression. Thus, it also serves to compare alternative regression models that may have been hypothesized. Finally, it has been emphasized that the method of least squares used in linear regression is applicable to a wide class of models. In each case, the model parameters are obtained by the solution of the so-called normal equations. These are simultaneous linear equations equal in number to the number of parameters to be estimated, obtained by partially differentiating the sum of squares of errors with respect to the individual's parameters. Regression is thus a potent device for establishing relationships between variables from the given data. The discovered relationship can be used for predictive purposes. Some of the models used in forecasting of demand rely heavily on regression analysis.
We were listening to the audiobook by the School of Management Studies IGNOU for MBA program, course code MMPC 005, Quantitative Analysis for Managerial Applications. Voiceover by Harpreet Kaur. Edited by Savita. Program assisted by Tarannum Jahan and Jagbandhu Jana. Program produced by Dr. Manoj Kumar Singh. This program was brought to you by Electronic Media Production Center of Indira Gandhi National Open University.